Right, you got page 12? Don't worry, I've got my own calculator today.
So today we just loaded back.
Yes, I see very little point in starting the final section of the course like a day before the holidays. So we'll just start it when we come back and we'll do revision today and tomorrow. Okay, do you have it there, page 12? Alright, I think we'll just do this one together and maybe the next one we'll take turns. Good. So the first part is define resistivity. So in fact we did that yesterday. Ray, where were you yesterday? The whole day? Dude. Alright, so define resistivity. We did that yesterday. Resistivity is a constant for a material, and what's the unit? It's measured in ohm meter. So let's try and give a definition. Resistivity is a constant for a given material, and the unit is ohm meters, such that a higher resistivity, and I'll give the symbol as well, is a rho, such that a higher rho results in the material offering more electrical resistance when a current, put those stolen wine gums away, when a current is passed through it, i.e. resistance equals rho L over A. I mean, it doesn't have to be exactly like that, but I'm just looking for you to explain the idea that a bigger resistivity results in more resistance.
So we just said that there's a material for resistance to flow current through.
Yeah, but just make sure you at least mention that.
With the formula.
No, that a bigger value corresponds to more resistance. What's wrong, Tal? Tal, what's wrong?
What? I'm not even doing this.
Yeah, but my spider senses are telling me you might do something now.
You never know.
I feel like I do, though, that the answer is yes.
A bigger area.
Joshua, what's your back there? I think he's up to no good. No, I don't think you need to mention the area. It's okay. I just care about the constant right now. Alright, can I scroll down?
No.
Not yet? Okay. You're right there, Joshua.
Yeah.
You sure?
Yes, sweet and being hiding there.
You're really sweet.
During the fast. What was it called?
Fine, you think so. Alright, can I go to the next part? Is that right? You only took them from Charles, so it doesn't count. Alright, can I scroll down now? So part 2 is a calculation of this. So you have the length equals 2 meters, the resistance equals 10 ohms, and the radius is equal to 0.55. Oh, sorry, that's the resistivity. Am I looking at the wrong part? Yeah, sorry, that is that, that's that, and then the resistivity is 1.1 micro ohm meters, and the length is 2. Right, and the question is, what's the diameter? So, I mean, that's very straightforward. We have R equals rho L over A. So A equals rho L over R. So pi R squared equals rho L over R. So that means R equals rho L over pi R square root. But we want the diameter, which is 2R. So it'll just be 2 root rho L over pi R. So if I type in all the numbers, 2 with a root and a fraction, rho, which is 1.1 times 10 to the power of minus 6, times the length over pi times the resistance, which is 10. And I get a small answer, which I should, because it's usually a wire, not even a millimeter, it's 0.529 millimeters is the diameter. Right, part 3 now. The wire is used in the potential divider circuit as shown. So that's the AB, yeah. Can I scroll down? Yeah. Now, I don't know if you remember exactly how potential dividers work, but it's not too big of a deal if you don't. You have a 12 volt power source, and then you have this resistor that we had a moment ago, but it totals 10 ohms. However, the resistor is then broken into 2 pieces, and when you determine the length, the nichrome wires use the potential divider below. Yes, I think the diagram is not super clear, but they're basically saying that the voltage here is 3 volts.
So that the voltage going in and the voltage measured?
That are measured, yeah, see, I know they mean the voltage measured as if it was a voltmeter, but it almost looks like that they're saying there's another 3 volt power source, which I don't think is what they mean at all. Anyways, there's 2 ways to look at this. They would like to know the length L2. They want the length here. Now the first way to do it is by using the formula. You have R equals rho L over A. So that means the length is RA over rho. But we don't know the R. We don't know the R. So then what we could do is use Ohm's law, V equals I/R. So then we get L equals V over, V A over I times the constant. Now that's good because we know what the V is, it's 3. We can know the A and we can know this, but we don't know the I, but that's okay because we can easily get the I. V equals I/R. So you get 12 equals I times 10. Here I'm looking at the total. This is the total. So then I is 1.2. So now you have enough information. Now remember, I said there are 2 ways to do it. This is just one of the ways. So let me type the numbers in. Fraction 3 times pi times radius squared over 1.2 times 1.1 times 10 to the power of minus 6. I got a half exactly. L equals 0.5 meters. Now I said that's just one way of doing it. The second way to do it is as follows. You know that the total voltage is 12. Okay? 3 volts are used up in the lower half, the lower portion of the resistor. So then, therefore, what is the voltage used up here? 9. The great thing about these simple potential divider circuits is that they're all proportional. What I mean by this is 3 to 9, the voltage ratio is going to be the same as the length ratio. So I could have said, for example, if this length I call it L, then this length here must be equal to 3L, because its voltage is 3 times bigger. It loses 3 times the voltage because it's 3 times the length, and length is a proportional variable. Therefore, you get this much shorter way of doing it. 4L equals 12, so what does L equal? 3, no, not 4L equals 12, sorry. 4L equals 2. It's 2 meters long. So what does L equal? 0.5. Now you can see the second way I did it was much quicker than the first way, but I just wanted to show you that, you know, there are often many ways to get to the answer. Let's have a look at the next part. Part 4 is a 5 ohm resistor is connected across the output. Determine the potential difference across this resistor. Okay, so I need to draw it again. Can I go down?
Yes.
So in part 4 now, what you have is a 12 volt power supply here. And we still have our resistor. Oh, by the way, if the total is 10 ohms, and this here is 1/4 the total length, what would its resistance be? The length of this resistor is 2 meters. The lower resistor is half a meter long. Therefore, it is 1/4 the total length. So, all right. Brains activate. Right.
Denied.
Huh?
Access denied.
Access denied, yes. Yeah. The file we're looking for is not found. Never mind. We can calculate the resistance in each of these just by using the formula R equals rho L over A. What's the length of this piece here at the bottom? 0.5 meters. And this one here? 1.5 meters. So when you use this formula, you'll get here 2.5 ohms and here 7.5 ohms. But once again, they're in the same proportion. The voltage, the lengths are 3 to 1, so the resistance is also 3 to 1. Remember that the total resistance is 10 ohms. If you don't like that, if you know likey that, you can just use this formula. Yes, you know likey this.
That is 5 ohm.
5 ohm? There's no 5 ohm. Huh?
The 5 ohm resistance.
I haven't drawn it in yet, please. I'm not finished the diagram. I'm just drawing in the first 2 resistors. You just give me 20 seconds, okay? So we put in the second resistor here, it says, and this resistor is 5 ohms. Okay, Tanish? What? Huh? Potential divider is just like this diagram. It's a battery and 2 resistors. and the voltage in each resistor will be different. It basically takes the battery and splits its voltage into two. So this one here is taking 12 volts, well, previously it was taking 12 volts and splitting it into 9 and 3 volts.
So the three parts is the potential divider.
Oh, the whole thing is a potential divider, it's called.
How do you know it's as a 5 ohm resistor?
It says a 5 ohm resistor is connected across the output of the potential divider. That is the output is this piece here, sticking out. Okay. And this here is the input. Yes.
But initially, like that's one. That's 12 volts, and initially there was no potential divider of that side. So
Initially there was no 5 ohm resistor, there was a voltmeter.
Yes.
Yeah.
There was. Oh yeah.
Proceed? Yeah. Alright. Hey, Cal, please, dear right, come on. Cal. So here they want the voltage here. That's what they're looking for.
And we find the total resistance, 2.5.
You could find the total resistance, and this total resistance would help give you the current. You could do it this first. So we'll go with first total resistance. So here we have 1 over R equals 1 over 2.5 plus 1 over 5. So this is 5 over 3. This is 5 over 3, and then I add it to 7.5. So in total I'll get 55 over 6, or 9.17. Now I have V equals I or, so I equals V over or, so that will equal 12 over this answer. So that is 1.31 is the current amps. So the current here is 1.31, 1.31, 1.31, 1.31. So what happens here?
1.31.
No, it splits. So here is like an I1, and then here is an I2. I2, I2, and then it goes back here to 1.31, and here is 1.31. So, what rule should we use now? I think we'll use Kirchhoff. I1 plus I2 should equal 1.31. Yeah? Also, we'll use a loop rule, I think, as well. Which loop will we take? We'll go 12, then we'll go, yeah, we'll just take the first loop, I think. If I go 12 minus 1.31 I or 7.5 minus I1 times 2.5 equals 0. So I've used a junction rule and a loop rule. So now I can get the I1. 12 minus 1.31 times 7.5 divided by 2.5. So I get I1 is 0.87. And therefore I2 is 0.44 amps. But what are they looking for? They're looking for...
We don't need I2.
No, but we need it later, you see. I've accidentally, so to speak, done the next part where they're looking for current.
So basically there was another one.
Oh yes, there was, yeah, but I really like using Kirchhoff for these problems here because I know that later they'll be asking me things like what is the current and so on.
Can we, if x is solved,
Yeah, that's fine. Just mark.
Should we rewrite it or?
No, just beside your answer, write like part 5 answer or something like this. I'll show you what I'll do here. They're looking for the V here, so we can say V equals I or, and the I is I2, which is 0.44, and the or is 5. So I get that V equals 2.2 volts. So this is the answer for part 4, but they wanted the current flowing in AC. That is the I1. So this was the answer for part 5. And then they want the current flowing in CB. That's the that's the CB, that's I1. So that's actually part 6. And the current flowing in AC, where's AC? Oh, no, AC is the 1.31, which is, where did I write that? Here. This is 5. So this was the answer for part 5. This is the answer for part 6. And this is the answer for part 4. Now, we talked about the, what's wrong? We talked about, yes, Hamish?
To find the current of the whole circuit,
yeah.
You have to find the resistance of the lower circuit adding with 7.5.
Yes, which is exactly what I did, Hamish. That was 9.17 in total.
I think that
I1
is that.
Part 5 is the current in AC. This is before the current gets split. Yeah. Do you remember before I said in the physics exam, sometimes it is easier, or at least more convenient, to do the second part first. In this question, I found it more convenient to calculate the currents, which they're asking me for in part 5 and 6, before getting the voltage, which is actually part 4. So if you look at the order, I actually did part 5, part 6, and then part 4. This is no problem in the exam. How many marks for this here? It's actually 7 marks. Okay. But Tom, as you pointed out, there must have been some other way to do this if they had the order the way they did, and I suspect it was through a series of Ohm's law and potential divider equations. But this just seems very messy to me. Kirchhoff is a much neater way to do it. Okay. Alright, let's look at part B. So can you go to the next page? Part B. It's our buddy Kirchhoff. You must learn to love Kirchhoff. He is your friend. No? Alright. So let's draw the circuit. We have an 8 ohm resistor. Then the current splits into 2. And then we have 2 batteries. And then we have 2 resistors. And then they reconnect. And then we have a big 10 volt battery here. So let me just mark in everything. So I'll do voltages in red. What's wrong? Yeah? For what are we talking about? Resistance or current or what? Voltage. If you're going from positive to negative and you pass through a resistor, it's a subtraction. But look, I think this issue comes up in this diagram, so we can talk about it. So this is a 10 volt. This is an E1 voltage. This is a 16 volt. And then in blue, this is a 6 ohm. This is a 4 ohm. This is a 2 ohm. And this is an 8 ohm. And we know the current as well. So current in green. This is a 2.1 amp. 2.1 amp. 2.1 amp. And then it splits into an I1 and then an I2. I1, I2. I1, I2, and then it reconnects back to 2.1 amps. 2.1, 2.1, 2.1. The question is asking me for what? What do I need in the question? Here, I'll turn the light off, make it a bit clearer.
I1 minus 2,
Yeah. So they want you to find the three things here you don't know. E1, I1, I2. I'm completely ignoring the order they ask me to find it. I'll just do it with whatever way feels easiest for me. Basically, they broke the question into three parts, but it really is one part. Find all the unknown terms. So we have to use loops and junctions here. So firstly, junction rule says 2.1 minus I1 minus I2, that's here at this junction, that equals 0. Or in other words, I1 plus I2 equals 2.1. Okay, now we need to do loops. How many loops will we need to do here?
3.
No, not 3.
2.
Yeah, I only need to do 2, but I could probably do 3, isn't it? So we should choose our loops carefully. My first choice is to go on the inside path. If I do that, I would have in my formula an E1 and an I1. Okay, if I go on the outside loop, I have an I2.
You should find I2 straight.
Yeah, if I go on the outside loop, would I only have I2? Yeah, so that's really nice. So I should definitely go on the outside loop. And then what about the small loop? I'd have an I1 and I2 and an E, which I probably need to use at the end to get it.
You just have I1 and E1.
You can just
Yeah,
the
yeah.
outside and the inside loop. That's all.
Yeah. Let's go do the outer loop first. That can give us I2 directly. Now look at this. This is really funny. We just all realised that if we take the outside loop, what could we find? I2. But what did they ask me for here first? I1. So again, yes, I know. Again, I remind you that the order of the question is not always the best way to do it. So we'll get the I2 first. So we have 10 minus 2.18. So Joshua, when the current passes through the resistor,
The resistor is asking about the battery.
oh, okay, well we'll get to a battery in a moment. Minus 2.18, and then we get to this battery here. Will this add or subtract to my voltage? Add, yeah, because the batteries connect positive to negative terminal. So that is a plus 16 minus 6I2 minus 2 times 2.1 equals 0. Is that okay? That's the outside, the outermost loop.
If the second battery would be connected in the direction opposite to the
Yeah.
first one, it's subtraction.
That's the only difference, yeah. Yeah.
That's 0.833.
Hang on, I'll check it. What did you get, Joshua?
0.833.
Good job. So I2 is 0.833.
Now we can find I1.
Yeah, then we can find I1. So this is actually my second equation, which is also my second answer. So we have our second answer and our first answer. I1 is 1.27. I2 is 0.83 amps. So I've done the part, this is part 2. This is part 1 and this is part 2. So finally part 3 is the E.
Let's take this one.
The small loop, yeah. So we'll go with, we'll start with the 16. 16 minus 6I2 plus 4I1. Now if I'm going this way around, this is a subtraction of E1 equals 0.
16 volts.
16? It is. So my third equation is actually my third answer also. E1 equals 16 volts. So E1 is 16 volts, and this is my answer for part 3. Now let me just check that answer there. Let's make sure we got it right. Okay. That'd be the person I'm married to. Physics. What year is this? 2014 version 1 mark scheme. Isn't it? Last question? Yeah.
0.1.
Oh yeah, 16.08, so that should be rounded to 16.1. But it's 1.27, 0.83. What's the other answers? 8.27? 1.31? Yeah, it's all right? Okay. Wait, what? I'll check here. 0.87, 2.2 and 1.31. 1.31, 2.2 about 0.87. Yeah, okay. What's on? Great.